Hey guys, we're up to the final example 8 of the textbook. I know it's been a long set of videos. Analyzing a lemniscate curve. Notice this one is r squared and 2 theta. It's very specific to 2 theta. This appeared once, I believe, in BC calculus, so this is, at this point, I would guess purely enrichment. Notice the domain is a little bit more interesting here. So let's go ahead and take a look. Oh, that's how it looks. Looks like an infinity sign. But I want to show you some graphical things too to figure out how we look on your graphing calculator, because if you put in your graphing calculator, it's going to end up looking like this. Notice your graphing calculator has a missing chunk here, and the reason why is, if you think about it, if I'm going from 0 to 90, the radius has to pull in, right? But look at how drastically quickly it pulls into 0. So that means for the smallest amount of radian measure, that radius is being pulled in really fast. It's decreasing, hitting 0 really very rapidly. So that's why your calculator is not calculating enough values of theta to small enough increments of theta to actually, it goes from here all the way to 0, because there's a bunch of theta values that were never calculated. So if we go to your window, the way to actually make your calculator calculate and show more of it is to make your theta steps smaller. So if I made this point, clear it out, 0.05 and graph, notice I get a little bit more, but that's still not enough. So I can go there and make it 0.01, hit graph. But the problem is now I'm asking the calculator to do a lot more, and there's still a gap over there. And notice there was a time where it wasn't doing anything, and that has to do with the domain. So we'll talk about that in a moment. But you guys get the idea. So that's how it looks like. Now, why is it missing petals? Now, the reason why it's missing petals is that square root part. If I were to solve for r squared, I'd have square root both sides. I'd have r is equal to the square root, right? Square root both sides. Get 2 square root of cosine 2 theta. Now, if I want to know about cosine for sections, this section over here, cosine comes out negative. So it's pi over 2, pi, 3 pi over 2, 2 pi. That middle section would be negative, which means it's undefined for square root. So that means the domain is only from 0 to pi over 2. But since it's 2 theta, then we'd have to say, oh, well, when is 2 theta is equal to pi over 2? And in this case, it would be pi over 4, which means from 0 to pi over 4, that's part of the domain. You do this, extend it out farther to get the rest of this. But again, don't worry so much. I'm not gonna get asked or tested on this, since you're, it's distance learning. And I have a feeling by this point, example 8, there's only a few of you that are potentially seeing every video for every second and what it is. So congratulations if you made it all the way to example 8. Give me a shout out. If you made it this far, might go a long way in your recommendation. So hey, let me know, wink wink, right? With that said, let's graph this very quickly. The most you can be is 2 units away, this way and this way, and it would just end up looking like that. And we wouldn't have this part because that's that undefined section from here to here, right? 0 to pi over 4 and whatnot, or like this, right? You wouldn't have all of that with the negative radius. All right, that is it for 6.5, we're skipping example 1 because I'm not doing the symmetry substitutions test. All right. Have a good one.